Okay. Hi, this is Let's Discuss the paper soon after reading it. So we had chosen the paper about consciousness and read it for 2 hours. And from now, we will discuss it. First, we will introduce ourselves. So I'm Ryoichi Watanabe, a PhD student at Kyoto University, Japan. So please, Aria.
Hi, I'm Aria. I'm a master by research student at the Dynamic System and Neural System groups at the University of Sydney.
Okay, thank you, Aria. So today we read the paper titled The Strengths of Weak Integrated Information Theory and written by, Pardo Mediano, Fernando Rosas, Daniel Bohr, Anil Seth, and Adam Barrett, published by the Trend in Cognitive Science and June 2022. So then I will summarize this paper briefly. So in this paper, the authors introduce the classification of strong and weak IIT and discuss the advantages or disadvantages of each. So in addition, the authors discuss the application of weak IIT to experiments. So as many of you know, IIT is a theory of consciousness that sets the axioms and the assumptions from the phenomenal aspects of consciousness and challenges the mystery of consciousness, mainly in terms of informativeness or complexity and integration. So in contrast, other theories of consciousness like global neural workspace theory or higher order theory or something attempt to explain consciousness from the mechanism of brain process or cognitive function, like metacognition, meta thought. So when trying to explain consciousness from the material mechanism or a brain mechanism or functional mechanism, we run into hard problem. But the IIT approach is expected to be able to explain the material side of consciousness from the phenomenal side through information. So in this paper, our IIT are divided into strong and weak IIT for discussion. And table 1 is clearly classifies these two characteristics in the paper. So very simply, I will explain. A strong IIT reflects the assumption of the IIT itself, first IIT itself, and the strong IIT challenges the hard problem and refers to the relationship between consciousness and the causal effect structure of integrated intrinsic information. And the theory is also adaptable to all physical systems in the world and focused on the theoretical foundations and strictness rather than implementation or practice and measurability. Then weak IIT, on the other hand, aim to elucidate realistic or real phenomena of consciousness and measures real phenomena of consciousness and measures the characteristics of each consciousness or property and the correlation of neural activity as the informativeness or phi. Therefore, the focus is not on explaining the entire substance or system, but on calculating the amount of information in the underlying neural system and measuring real-world brain active data or experimental data. So finally, so strong IIT is difficult to adapt to actual experimental data. But on the other hand, as a theory of consciousness, it allows for basic and mathematical clarification of consciousness it's a good point, advantage point. In contrast, weak IIT, on the other hand, are difficult to explain overall consciousness or general consciousness, but are adaptable to real world or experimental data analysis and can continue to accumulate evidence. So it is important to combine research on both weak and strong IITs. So this is my super brief summary of this paper. And if you have addition or comments, please.
Yeah, I think the only additional comments that I have for this is at the later part of the paper, where the authors went into more details on the particular cases and examples where they show the strengths of the weak IIT as opposed to the strong IITs. For example, when certain strong assumptions of the strong IIT is relaxed, for example, with the perturbational complexity, where how the PCI index is not quite, they correlate highly with the ideas of IIT, but there's some kind of discrepancies, and how the why by relaxing certain assumptions of the strong IIT, the weak IIT can help address that, and how it's matched better for experimental results with the, due to all the difficulties of IIT measurements due to the potential complexities and everything. Yeah.
Okay, thank you for addition. Yeah. So in this paper, I briefly summarize, but in this paper, the example is more. So if you read or audience read, please read the detail or unthink it. And then if you have a question or wondering about this paper, please ask or comment. I think for me, yeah, I'd like to adapt the IIT to the experimental data. So for me also, so I learned this theory, but I think the IIT is more related to the level of consciousness, right? So so I'm wondering how to adapt the experimental data or contents of consciousness, like the in other words, curious or something. Yeah. So do you know, or do you have any idea or comment?
Yeah, so I think I like the kind of like the premise in the papers on the kind of signal out the strengths of the weak theory of IIT, but in my view, it's not so much like a kind of like a new set of theories, but it's rather how you kind of translate the kind of like theoretical foundations of the strong IIT and relax some of those assumptions, and then you can kind of adapt it to experimental data, like you said. So to me, it's not so much like a kind of like like a new kind of like flavor, but it's like kind of more on how you translate the theories to the kind of like practice side. Yeah. But at the same time, I do feel like the one of the main strengths of the IIT theory is on how it addresses the issues of identity, and also the kind of like the uniqueness of the experience with the kind of the strong assumptions of the maximal information. And why for when you relax all these assumptions with the weak IIT versions, they don't address these problems. So and then I feel like the and also the strong IIT one is a unifying framework. Why with the week one, you kind of break it down to like several different assumptions, several different like kind of hypotheses, and you kind of test it out. So there's no kind of like overarching framework in that sense. That's what I feel.
I see. Yeah. So strong IIT or general IIT is constructed by the weak IIT proponent, right? I think strong IIT is more related to the level of consciousness, or really what the we have a consciousness, or we have a conscious, or we don't have a conscious.
Yep.
So the brain, all brain activity or something. But weak IIT can examine the detail of the detail and the module of the content of consciousness, or like the visual consciousness. So more specific visual NCC, neural correlation of visual consciousness, or audio consciousness, or tactile consciousness can weak IIT can examine it. But strong IIT is more, for me, more related to the level of consciousness and how to adapt to the more detail or something.
That's not so clear to me from the paper, because I think one of the axioms of IIT is the strong, the composition. And so then my understanding is that if you kind of like have that kind of composition as part of the framework of IIT, then you would have experience, like kind of not just the values, but also the quality of the experience. Yeah, so it's not just like a binary conscious or not conscious, but there's also like kind of like the level of consciousness and the quality, the characteristic of consciousness. And I think they address this like in kind of some of the examples with like different states of consciousness with under anesthesia, so under psychedelics and things like that. But yeah, I think like you're right that in actually examining these kind of like, it's like then you need the weaker assumptions for that.
I see. Yeah, I see.
But that kind of like brought me to actually questions that I had when I had read the paper earlier, when the author addressed the multidimensionality of the framework, and he says that and they kind of propose a path on how weak IIT can approach that with by involve separate measures that kind of map to different kind of I suppose like states and types of experience of consciousness. So it's on page 7, like a path from multidimensional weak IIT. I'm not sure by multidimensional here he meant the actual like like the compositions of the consciousness, or is it like something else?
I see. Now I look for a second. I see. A path for multidimensional weak IIT, right?
Yeah.
I see. So many or some studies use the entropy or of as this measurement of the or informative conscious informativeness of consciousness, right? So the unit is sorry, I cannot I don't understand your comment. So
yeah, my question is just by like the kind of like aspect that they talk about here, the multidimensionality. So is it the same thing as the compositions that the original IIT address, or something else?
I see. Yeah, multidimensional. Yeah. I also don't understand this. So multidimensional. Second choice. Yeah, so and in this word dimension mean what? What dimension? Dimension is what word?
Yeah, I think in the second paragraph of that one, it says one might quantify to what extent additional properties are reflected in neural dynamics, such as composition, diversity of information, as distinct from the overall quantity of information. So I guess like, yeah, that probably dimensions like includes both the compositions and the diversity. Yeah, okay, yeah.
Yeah, I see. Yeah, so let's discuss something out of this paper. So, so I think you measured the machine learning or some machine learning. You study or you run.
Yes. Yes, so my background is in my undergrad background is in mathematics, and I've been working in the machine learning field. Yeah.
So you want to adapt the IIT to your study or your study or studying consciousness, right?
Yeah, so I've been quite interested in this area of like the theory of IIT. So I'm still like reading on, you know, like other papers around and just like kind of like different like flavors and different versions of IIT, still trying to get my head around those concepts. But I guess like coming from a mathematics background, like I really like the overall idea because it's very mathematically elegant.
Yeah.
Yeah. And for this paper, I really like the development that we're talking about on the decomposition part, the partial, the PID part. It's yeah. But I think that part is like really like it's very early now. So yeah.
I see. So sorry, I'm not good at mathematics or so measurement. So in this paper, so the measurement of phi is a lot. So I mean that phi WMS or phi asterisk disk or phi something. So yeah. So
many versions.
Yeah, version. So yeah, so no, phi measurement are so many, but we can integrate or we can translate these measurement. For example, you can translate from the phi asterisk to phi WMS or phi something to phi max or
yeah.
it is possible.
Yeah, I think
right?
so, but I think they probably have different kind of theoretical constraint for each. So I think probably some is more complex. So maybe the with our kind of existing computational resources, we can only have like I think with the original file, it's probably like we can compute up to 12 elements. I think that's what figure I got like maybe a few months ago. I'm not sure if that has changed, but maybe with more complex file, then maybe that number is like reduced in terms of the number of elements in the system that we can measure the file. So maybe like with like kind of like a smaller system, we can translate between different file values. But with larger system, maybe you can only like compute like simpler kind of file. Yeah,
I see. Oh, nice. So more simplest file we if you can, or if you can, how to say, set or make and calculate it from the other measurement or other file, we can easily to understand. For me, easily to understand these calculation and so how calculation and the aim of these formula or mathematical formulation, because if audience, or I don't study more the mathematical translation and formula. So when I see the formulation, but I cannot understand this, what the author do it or translate it. So sorry.
Yeah, I think I read those like different versions of files like a while ago. So I don't remember the exact like kind of calculation either. So, but what I was saying earlier on, like maybe like more higher version of files, probably more complicated to compute. It's also like just my guess, because like when you introduce more complexities, then it takes more computational resources to compute. So yeah.
I see. So I think we discussed for 2 or 3 minutes, 20 or 30 minutes. So do you have anything to discuss or comment, want to say?
No, I think it's yeah, I think overall I think I like this paper as kind of like a good like overview of like, you know, like different versions and how we can like relax the assumptions and contribute back to the overall like kind of literature of IIT. And there's definitely some kind of like mentions on some current developments on the like the empirical data, like different empirical measurements and PID part, which is quite interesting. And yeah, I think I might just like go into some of the references to read on the but I think I enjoy like the paper overall. Yeah.
Yes, so I think I agree with you, and this paper is good for us studying more to understand the IIT and how to adapt our experiment or our study. So it is good paper, I also think. So we will finish this discussion. Okay. So see you next time. Bye.
Okay. See you. Thanks, Ryoji.
Thank you. And